In this crop protection project, funded through DEFRA's Farming Innovation Programme and delivered in partnership with UK Research and Innovation, CHAP and Back2Bio have collaborated to harness novel compounds from untapped soil bacteria to control foliar diseases in wheat.
Here we are at Rothamsted in the field of winter wheat, the most widely grown arable crop in the UK. It is susceptible to a number of foliar diseases such as Septoria. These tend to be controlled using synthetic fungicides. They're not always sustainable and they're becoming less available to UK farmers. So we need to think of more sustainable ways of controlling diseases such as Septoria, looking to bacteria to provide the compounds to control these diseases.
Bacteria are the most diverse bioresource in life, and they produce an equally diverse range of chemicals. Those chemicals have historically been used across a variety of different areas, including antibiotics and fungicides. The really interesting thing about microbes is that they grow in communities, and so you're only able to grow the 1% of microbes normally that grow outside of those communities. What we do in Back2Bio is that we combine bioinformatics, next generation sequencing and machine learning in order to understand how those communities grow together and under which conditions.
Together, the project partners set out to improve high-throughput screening methods for discovering new bacteria, discover new fungicidal compounds and optimise their extraction and production, verify fungicidal activity against Septoria under laboratory and glasshouse conditions, patent novel compounds and raise awareness of project outcomes to relevant stakeholders, including potential buyers or customers.
Our platform at Back2Bio can broadly be broken into 3 distinct steps. So that's microbial generation, which is the generation of novel microbes, compound discovery, which is looking for the valuable compounds that those microbes might make, and commercialization, so that's turning those compounds into value. To date, Back2Bio have generated a library of over 2,000 microbial species. Within that library, we have unique access to around 5% of bacterial species that have ever been cultured. We're now seeing the genetic diversity in our library correspond to chemical diversity, and we're looking forward to developing these novel compounds that target and kill a number of different pathogens.
During the project, Back2Bio have discovered 900 new species and 6 compounds with potential activity against fungal diseases. CHAP's role in this project is to see how these new compounds perform when applied to wheat plants infected with Septoria. Alongside this trial work, CHAP provide project management, ensuring delivery on time, in scope and to budget.
Here at Rothamsted, we received different extracts that had been purified by the Back2Bio team. We resuspended them into water, and the way the experiment has worked is that we've taken individual leaves of wheat plants, treated them with the different chemicals, and then we sprayed spores of our fungus onto those leaves, incubated into some cloches to create a high humidity, and then carried on growing those leaves to see whether they get disease or not. We can then score that disease and assess whether the novel bacterial chemical has protected the leaf against the fungus or not. So far we've already scored our first run of the experiments, and we've found some really promising results. 3 or 4 of the different chemicals have made substantial reductions in the amount of disease, some of them virtually to 0 disease, which is easily equivalent to what you'd get from a really good fungicide. By using the bacterial exudate as an alternative product, it means we can maximise disease control for the farmers. By controlling the disease, we're growing more yield from the same unit area of land. So actually, by using good crop protection, we reduce the carbon footprint of growing the crop, and it safeguards the food supply so we don't have to import any food either. All round, it's actually better for UK growers and just the environment in general for us to have good crop protection.
Innovate UK funding and working with CHAP has been instrumental for our development in terms of fungicide development. So CHAP have been there helping us ideate the project, execute the project, and we're looking forward to working with them to exploit the projects in the future. But fundamental to this project was the public funding from Innovate UK that has allowed us to expand in a technology area that we previously hadn't explored. and in doing so has attracted additional investment from key major players in fungicide development.
It's great to work with innovative cutting-edge companies like Bacter Bio and help them with applying for and winning grant funding opportunities such as this. This project has generated a lot of interest, as we've seen from sector engagement, and this really shows the importance of projects like this to drive forward innovation and providing new solutions for crop protection both now and in the future.
Looking at where we're at, this grant enabled us to lay the foundation to find biopesticides for Septoria. It's also enabled us to follow on with another grant with CHAP for 230,000, where we target late potato blight. And from there on, we really do want to use this as a springboard to target food security and overall, and target many more diseases and find safer and cleaner biopesticides going forward.
As with all the companies we work with, we're pleased to be able to build upon this project with Bacter Bio. Ultimately, at CHAP, it's our mission to be a catalyst for the development, discovery, delivery and adoption of applied agritech to have an impact worldwide.
If you're interested in learning more or want to know how to get involved in these types of projects, then please contact the CHAP team at enquiries@chap-solutions.co.uk or Bacter Bio at info@bacto.bio.